Hello everyone, welcome to Physics 101 by Tejas Anand. आज हम पढ़ेंगे how Bernoulli's principle is applied in the concept of bowling. Okay, so velocity is inversely proportional to pressure. Where there is high velocity, there is low pressure. Remember this: where there is high velocity, there is low pressure, and things move from a medium of higher pressure to a medium of lower pressure. Look at this example. When you are moving in a car and you take your head out of the window, the car is moving with velocity v, and you are peeking out of the window. Then you experience some force, some drag in the backward direction. Right now, here we have a ball, and suppose we rotate this ball with our hands. It is kept on a table, and we rotate it with some omega angular velocity. Now, what happens here is this is a ball, and this is rotated with some omega angular velocity in the anti-clockwise direction. Here at this surface of the ball, if we draw a tangent, we would get the direction of that velocity of that particular point, and since it is moving in the anti-clockwise direction, we'll get a velocity in this direction. Now, if we keep a human being over here, like there are suppose air particles here, and there are air particles here as well, and if we keep a human being here at the surface of this ball, since at this particular point the tangent is in the forward direction, this human being will experience some drag in the backward direction, and again if there is a human being here, he will experience some force in some drag in the forward direction. Now what really happens is, if the bowler throws a ball while it is spinning, so here is a ball, it is moving, it is spinning with some angular velocity omega, and it is simultaneously moving in the forward direction. Now, when it is moving in the forward direction, the whole ball will experience some backward force, right? And at this component here, these air particles, due to the spin of the ball, they'll experience some extra force here, and at this component in the forward direction, and obviously this side was experiencing also some, sorry, not in the forward direction, but in the backward direction. Like this, it's like this. So this was due to this arrow, due to the motion of the ball, and this is due to the spin of the ball. These smaller arrows and these bigger arrows due to the forward motion of the ball. Since and this was actually explained by this concept only. If you're moving forward, the car is moving forward, you peek out of the window, you'll experience some backward drag, right? Okay. Now, if we actually compare these things on the right side and on the left side, the velocity of air particles on the right side and on the left side, the right side adds up, it increases. The left side subtracts, it decreases. Therefore, this ball which is spinning and moving in the forward direction, the right side velocity increases and the left side velocity decreases. And where there is high velocity, according to Bernoulli's principle, since velocity and pressure are inversely related, there is low pressure and here is high pressure, and things tend to move from a medium of higher pressure to a medium of lower pressure. So the particles present here would tend to move here in this direction, which will cause a change of trajectory of this ball. So if the ball was supposed to go in a straight direction, when it was not spinning, it would actually change its trajectory due to the variable pressures. So technically it would go like this instead of going like this. And that's how bowlers do some like crazy magic shit. They easily take wickets of players. And one more thing, if you look closely at a ball, it has ridges, right? These ridges cause more turbulence in the airflow, which further change the trajectory of that ball. These ridges causes turbulence in the airflow, which further causes trajectory changes. Yeah, that was it. Thank you so much for listening to my yapping session.